Hello, welcome to the new episode of Data in the Hallway. I'm your host, as always, Ray Pate, Community Manager at PingCAP, and joined by my co-host, Daniel Van Eden, joining us from the Netherlands. Good to see you again, Daniel. And then we actually have a return guest today, which is our first. So Ahmad Ghazal, who is our distinguished engineer at PingCAP, and I had to look this up. Ahmad actually appeared on episode 5 where we talked about benchmarking, and Ahmad, you talked about HTAP benchmarking work that you were involved in. So it's good to have you back. It's nice to know that Daniel and I didn't scare you from the previous episode. So welcome. And then we're going to talk about a slightly different topic, pretty important and popular topic in databases. It has to do with database indexes. And then there was a blog post that was released like a week before Christmas, I believe, or shortly before. So there's a risk that it may have been slightly buried before people started disappearing for the holidays. It's a new feature in TiDB called TiDB Index Advisor. I think that's a full name, and we call it TiAdvisor for short. And I'll make sure to include the link to the blog post and other resources in the podcast description. So thank you, Ahmad, not only for authoring the blog post, but appearing on our episode to talk about it. So I guess, Ahmad, we'll start with something basic. I mean, for people that are not database engineers full time, like, remind us, like, what are database indexes and why is it important, and what are their purposes? So.
Yeah. Okay. Well, great to connect with you guys again, and was fun last time, and I'm sure it's gonna be fun this time too. Yeah. So for databases, indices is one major physical database design choice. So it's usually database developers or DBAs. They may selectively create indices that help performance. So the main objective is really about performance. There's nothing functional about indices. And in a nutshell, user queries a lot of the time, especially for OLTP, they go after a small portion of the data that goes through joins and aggregations or just simple scans from the table. And usually that requires full table scan. So scanning all the data, which is not efficient. I mean, it works, but it's not efficient. So indices is a way of kind of having a replica of the data or portion of the data sorted in a different manner. And the sorting allows, range predicates, exact values, and what have you, to go after only a portion of the data. So it doesn't have to scan all the data. And usually indices, they have pointers to the base table, to the primary data, if you want to call it that way, so that you can get the extra columns needed. And if all the columns you need from an index, you just don't have to go to the table, which is called the tower index. So that's in a nutshell what indices are used for. But it's usually a difficult problem picking the right indices because there's a trade-off. So, create indices, you get benefit from avoiding scanning all the data, which could be very expensive, especially for OLTP. But at the same time, creating the index requires storage, requires CPU, and also requires maintenance. So if you're adding data, you need to keep the index in sync or up to date with the table, which is going to make your DML, the inserts updates release, more expensive. So that trade-off is an interesting problem, requires expertise from users to weigh that trade-off and decide to create indices. Another complexity with this physical database design aspects of indices is that you have a humongous number of possibilities. Because you could have a single column index, you can have 2 column, you can have 3 column. And also, even within, say, 3 column, you could have different ways of ordering the index. What is the leading column, and so on. So it's really a difficult task for a user to actually pick the right index in that sense.
Cool. All right. Yeah. Thanks for the
Give you a long answer.
no, 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 no. I mean, thanks for the detail, and I think that recap is very helpful. I think, most people, I mean, even somebody that is not as technical as like me, sort of have a sense that, it's important for database performance, but I don't think we all appreciate the trade-offs that you just mentioned. I mean, there are consequences of, I'm being simplistic here, selecting column B I want that to be like, one of the indices as an example. So, I mean, knowing all this trade-off and pros and cons, like, you know, who or how does someone go about, you know, deciding on the indices for your database? Is it, I mean, I assume you're not just picking something out of a hat, right? Like, what's sort of the typical process that people go through, and, who sort of makes a decision on creating indices?
Yeah, so a simple, maybe a rule of thumb, if you have queries that have some predicates on a certain column or columns, and so that's maybe the simplest example. So that could be a potential index because that predicate can allow the database to access a portion of the data through that index because that index is sorted on those values. So if you say where X is between 1 and 3, so the index is sorted on X, you can go only in that range from 1 to 3. And maybe you have a billion row in the table, and maybe you have 100 rows in the table that meet this predicate. So you're going to access only 100 rows from that table. So that's a simple example of an index. You could also use indices for joins too. You could do so like the index can work on behalf of the table for doing the join. And that's maybe another example. Then you can look at the join predicates, and that also could be a potential index on those join columns. The same thing for the group by columns and so on. But the bottom line is that the database developer or DBA, whoever person who in charge of maintaining the data itself, will make those decisions, and they have to weigh in, the extra overhead of the indices. One difficulty also even for experts is that usually they work on one query at a time. It's very hard. That's one of the problems we address actually too here in this advisor, that it's very hard to look at 10,000 queries and try to figure out what is the best overall indices, and also look at all the loads and all the inserts and all of that. It's just impossible task even for the experts. So usually the creating indices by user is more of a reactive event where they have a problem with the performance, and that's what our experience with some of our customers too. It's they have a problem with the query and say, oh, okay, the first thing that comes to my mind, can create an index for that specific query, and they go analyze, they explain, which is the execution plan. We call it the explain. And then they try to figure out, what if I create an index? And then, it could be also trial and error. Many of the times it's trial and error, which is quite expensive from, system resources and also, the human resources too. I mean, database developers their time is very crucial, and this trial and error could be expensive from that perspective.
Cool, cool. No, I mean, thanks for the details and talking about, the typical process that a lot of people go through, some of the challenges that are involved. And I mean, Daniel, I'm sort of like turning one of my questions to you, I guess. I mean, you talk to a lot of our like existing customers, even prospects.
Mhm.
I'm sure this is a pretty hot topic, like in terms of, because people are concerned about different types of queries, like database performance, and is it correct to assume that this, you know, as you're talking with our customer, this is one of the bigger topics that come across. But
Yes, it's certainly
yeah.
one of the bigger topics.
Mhm.
And there are like multiple things to consider that, like, for example, if you have a table with, say, 5 columns, then it's not only possible to have like an index on each individual column, but also on combinations. And like with 5 columns, it's already quite a few combinations. But with any extra column, there are more combinations. And then you have like a gazillion queries. Then a lot of tables, a lot of queries. The problem gets more and more complex, but also the number of and type of queries and columns will change over time. So this is something that needs constant attention. And if you like make a mistake by, for example, dropping the wrong index, it can be quite a disaster. So it's really an important thing to have a look at. Another problem there is that the developers are usually in charge of the queries, and the DBAs are in charge of the database performance, and the index is like right in the middle of those two areas. So it needs cooperation. Usually that works fine, but that makes it a little bit harder even.
Right, right. I'm sure some involve like interesting conversations between the two groups, right? And then, yeah, I mean, I think the point I wanted to verify was that this is not like a topic just for the users, but I'm sure those questions come to the vendors like us as well. So that's, something that we have to be mindful of. And I mean, I think this is why, like, any tool that can help assist in making decision on indices is I think is helpful, which gets us to the topic in hand, like a TiAdvisor, that you can find more details on the blog post that I mentioned earlier. So Ahmad, talk about like what were our goals for the index advisor, and you can also like sort of move towards how this feature actually works for TiDB users.
Okay, yeah, sure. So, given all the problems we talked about and
Mhm.
Danielle also alluded to, it's really a very difficult task for users to handle. So we want to automate this process. It could be, partial automation in the sense that the tool can help the user gives an initial recommendation and they can review it and accept it. And I think in the future, it could be full automation where just the system is just going to go ahead and do it. We're taking the option of the first option for now, which most commercial databases have done that. I think going towards this autonomous database would like to do this fully automated in the future. So considering all these parameters, we're talking about a complex workload, number one. Number two is the thing that Danielle mentioned is that the explosive search space here. We're talking about even if you have 5 columns, you could have a humongous number of possibilities. Even if you think about a 5-way indices, even ordering them, you could have more and more options there too. Because usually the leading column may have an impact on the query itself. Because if you are ordering an index, you're really ordering it based on all the columns, but the leading column is the most important one in the order. So we have a big search space, we have a big workload, and we have a trade-off also between maintaining these indices and using them as well. So TiAdvisor took care of 2 problems for now, which is the complex workload and the search space. Try to help the user with. And I think a future extension here we will be also trying to handle the trade-off between the benefit of the index and the overhead from the index. So that's what TiAdvisor is about. It used some interesting heuristics to cut down the search space, because if you think of the search space, it is an exponential number of possibilities that a tool cannot afford to go through, which is a typical computer science problem, where if you have a search problem that's really explosive or exponential, people in academia, they may call it NP hard, and so on. The solution is to come up with a heuristic solution that really efficient and doesn't give you the perfect answer, but gives you a good answer. So that's what TiAdvisor does. It uses what we call a genetic algorithm. So the genetic solution is you start with a solution that's helpful and useful, and then you can mutate that. You can really modify it incrementally, getting better and better answers. So what this means is that TiAdvisor will first try to look for the best single column indices. And the way of finding a good index or a bad index, we have a kind of a heuristic cost with and without. So if you're trying to create a column on X, this tool TiAdvisor, with the help of the query optimizer, it will say, what is the cost of my workload? So the workload will be part of the input here, this complex workload the user will provide to the tool. And the tool will say, if I have this index, what is the total cost of my workload? And if I don't have X, what's the total cost? And which one is better? So that's maybe the basic concept of looking at the what if scenario among all this search space. So the search space concept is done incrementally by looking at single column indices, and then you're going to end up by a subset of those, right? I mean, you may have 500 columns total in all the tables. You may end up by having 3 single column indices, and then from there you go to the 2 column indices, building on top of that. That's why it's called the genetic solution, and so on. And for practical purposes, we have some limits on the size of the index, and we have tunable, which the user can change, and we have a limit on the total number of indices to control the search space. But that's in a nutshell what the solution and how it handles the search space, and how it handles the workload overall.
Cool. So when you use like a TiAdvisor for a user uses a feature, like what's the output of TiAdvisor? I mean, do you get recommendation on here are the indexes that you should create, or I mean, what are some of the typical output that people can expect?
Actually, the output is very user friendly. It will be the DDL itself. So it will be, TiDB compatible syntax that says, create index, etc. And they can copy paste that after reviewing it. So the full output will be a bunch of create index statements,
right?
And the user can do a fine review and then just take it as a whole or modify it.
Right.
But maybe here on the input, I did say that maybe indirectly, but the user, when they use the tool, they just going to provide a file with all the workload queries. So it just basically they have to provide the queries, the SQL queries that they are interested in,
right?
And and just the the table schemas and all this metadata related to the table. One thing to point out about the usability here, which is I think is interesting, is that the tool can be run locally on the user cluster, and then the tool will be able to get all the metadata on the cluster and do what if scenarios using the help of the optimizer. That's one form of the tool. Another way you could use the tool, you could use it offline, where the users goes to TiDB, experts or customer support, and say, this is they can export their metadata in a safe way, and then TiDB can run it, or TiDB personnel can run it offline on another box using like what if scenario. I mean, we recommend the first option because the tool will have more detailed information to make a better answer in that sense.
Yeah, but I mean, but it's certainly good to have
I hope I didn't make it that complicated.
Yeah. I'm sorry. Go ahead. I think I interrupted you, Ahmad. So you might want to repeat what.
Yeah, I was just saying. I hope didn't overcomplicate this, but.
No. I mean, I think even an offline option is helpful, because there are certain use cases where that's the only way you can practically use it, right? But go ahead, Daniel. Sorry.
Yeah, I think it's also really good for people to understand that part of the tool is standalone, but it also really integrates with TiDB to be able to run all the what if scenarios. So it's not just a third party tool like you might already have a few of, but it really integrates with the server. And by doing that, it's able to get really interesting results.
Right. Cool. So, I mean, next question is, I mean, are there for people that are listening or watching on YouTube, are there examples where people can see TiAdvisor in action, and where can people find them?
Yeah, sure. I think the GitHub. So yeah, the tool is available publicly. So the GitHub repo has information. They can download the source code, and there are a number of examples that they can run, including some standard benchmark like TPCH,
Right.
and it's also an example of our own benchmark that we talked about in the first podcast as well.
Cool. Awesome. Yeah, I think that's even included in the blog post as well that people can look at. But it's nice that, I mean, you provide examples with source code so people can actually experiment with them. And yeah, I think there's a subfolder, like the IndexAdvisor subfolder under PingCAP that I'll make sure to add a link in the description. But yeah, that's great. And then you mentioned earlier that, I mean, you're looking to, obviously add to the TiAdvisor feature going forward. What's the best way for community members to provide feedback or provide suggestions based on their use, or maybe there's a feature they wanted to see added to TiAdvisor?
Yeah, sure. They can maybe either create issues on GitHub, or they can reach out to, I guess, any one of us here.
Right.
So yeah.
Cool. Yeah, I mean, we have obviously Slack and Discord channel too, which are pretty active,
sure.
and constantly monitored. So if you have questions or feedback on our recently released feature, TiAdvisor, please let us know. And then again, it'll be the same like a subfolder where IndexAdvisor is in our repo, but you can find it in the episode description. So yeah, I mean, thanks for the quick tour of TiAdvisor, and then also tying it back to the HM benchmark that we talked about in the earlier episode. And I mean, since you're a returning guest, I mean, we have a tradition of asking a closing trivia for all of our guests to talk about where you live. But since you've already done that, you're in Los Angeles area, but we're recording this in January, in the winter, but can you tell people about what's winter like in LA or in Southern California?
Yeah, so yeah, typically it's really dry and nice, but dry also could be bad for us because we had drought for a couple of years. But in the last few years, including this year, we have quite a bit of rain, which is good. We welcome that. We need the water, so that was actually a good change for us. So, but I still go occasionally with shorts and t-shirt, in January. So we still have that advantage.
Yeah. I think I'm in different part of California, but I've been living in California long enough where, I complained about the cold, but, compared to other parts of the world, like where Daniel lives, it's nowhere near as cold as, what people typically go through. But, yeah, I mean, just a reminder that you mentioned, Ahmad, we do have winter here, even in California. So it's not always, sunshine and 70 degrees weather, unfortunately. So yeah, I mean, rain this time of the year is a good thing. So we don't suffer through another drought, but yeah, we're certainly not used to it, I guess. So cool. Well, thanks for returning, Ahmad, and hopefully, I'm sure we'll have you back if you're willing to talk about more advancements in TiDB or database in general. So
Sure, we'll be happy to do so. We have a lot of interesting work in the near future. So
right, cool, awesome. Well, thanks, Ahmad, and thanks, Daniel. We'll see or talk to you in next episode.
Great, thank you, guys.
Yeah, bye-bye.
Okay, bye.
Thank you.